Okay, guys, so green on the left, notes on the right. Most of us have it. Green on the left, notes on the right. Okay, so today what we're going to do, we've been dealing with linear expressions. The whole chapter is about expressions, but we've kind of focused in on linear expressions. Okay, right? If you take a look, we've added, we've subtracted. Now we're going to do something called, we're going to be factoring linear expressions. Okay, so let me show you what that consists of. So let me go ahead. Let's talk about our vocab first, obviously. The first word in this lesson is called a monomial. Everyone? Monomial. Now, as you guys get older, you're going to be dealing with binomials, trinomials. Think about like bicycle, tricycle, that prefix bi and tri. What do those mean? 2 and 3, right? A tricycle, it has 3 wheels, right? So 2 and 3, kind of, while you're talking about that, what do you think that means? That prefix? Just, it means 1. Yeah, good. It means 1. All right. So here's what your vocab says, your book says. It says a monomial is a number, variable, or product of a number and one or more variables. Now, if that definition doesn't look familiar, let me remind you what this is. It's a term. We've been talking about terms, right? Like combining like terms. Okay, that's what a monomial basically is. It's a term. Okay. So you'll get into more detail as you get older, but bottom line, monomial is one term. Okay. So that's not a huge part of today's lesson, but it will be in directions. So I don't want you to get confused. When you see that word, you know it is a term. All right, our next word is factored form. Everyone?
Factored form.
All right, so here's what factored form is. This is an expression expressed as the product of its factors. An expression expressed as a product of its factors. All right, so how many of you guys remember like prime factorization in elementary school, or like the factor tree? How many of you guys remember kind of doing that in elementary school? Okay, so that's pretty much what this is. When you get down to the bottom, factored form looks kind of like this. If you have a 12 and you're factoring it, that would factored form could be something like 2 times 2 times 3. That would be an example of prime factorization. You're factoring it out to be a bunch of prime numbers. Okay, 2 times 2 times 3 would be 12. That would be factored form. Now, the next word is this. Factor, everyone?
Factor.
Okay, here's what factor is. This is to write a number as a product of its factors. Okay? So in your little box, you can just put sometimes to write in factored form. Sometimes to write in factored form. Okay? So bottom line is, here's what this is. Factored form is like a noun. It's a thing. It's a way to write numbers. Factor is the verb, that the action you're doing to get it into factored form. Sometimes that is. So this, of course, is kind of what we're doing today. All right. So before we get started, let's go ahead and put our binders away. Go ahead and grab your worksheets, the 5-8 worksheets. All right, name, date, period up at the top. Name, date, period up at the top. Okay, so let's go ahead and let's focus in on the top of this worksheet first, okay? Because we're going to start by doing problem number 7. Now, before we do 7, I want to go ahead and take a look at the directions up here. So let's go ahead and read the directions really quickly. It says, find the GCF of each pair of monomials. Let's try that again. Find the GCF of each pair of monomials. Okay. So, guys, GCF. What does that stand for? You guys remember? Very nice. Greatest common factor. And a lot of times that's why you guys factored in elementary school or found, used factor trees or prime factorization. Okay. So, we are going to find the greatest common factor of each pair of monomials. So, for example, number 7, they give us two monomials. 16mn, comma, right? And then 24m. Those are our two monomials, right? Basically two terms. So, here is what we're going to do. All right? Step 1 is your focus is going to be on the number part of each monomial or each term. Okay? Sometimes they're constants, meaning a number by themselves, or sometimes they are coefficients, which they are right here. So we're looking at the 16 and the 24. Okay? Then what we're going to do is we're going to find the GCF of both of those. Now, you may have, I probably know of probably 5 to 10 ways of, right off the top of my head, of finding the GCF. All right? There's a lot of different skills out there. Knowing all of those, the one that I do like, and let's face it, all of them are time consuming, okay, but the one that I do like, that I feel that has potential to have the least amount of issues or least amount of mistakes that you possibly could make if you follow the directions on how to do it, is by using factoring T-charts. So if you've never heard of this method, we're going to go ahead and do it together. So I put 16 and I put a T underneath it. I go ahead and put a 24 with a T underneath it. Okay? Now, when it's just a way to organize our thoughts. Let's focus in on 16 first. Now, here's how you do a factor T-chart. Okay? What you're going to do is you're going to always start with the factor of 1, because 1 divides into anything. So 1, it's always the easiest one as well, right? 1, and then of course 1 times 16 gives us 16. Then you don't just jump around to all of the different problems or different numbers. You just go in numerical order. So we already put 1. Then you go to the 2. So remember, the divisibility rule is that if this number is an even number, then 2 can go into it. So 2 goes into 16 8 times. So 2 times 8 is 16. Now 3, okay? 3, if you don't know, a lot of people don't know this divisibility rule, but you can tell if 3 goes into a number by adding the 2 digits of the number. So for example, 1 plus 6 is 7. Then you test it. Does 3 go into 7? No, it doesn't. So that means 3 can't go into 16. Okay? Now, 4. We do know that 4 goes into 16 4 times. Now listen, here's the neat thing about a T-chart also. Once you get to a number and it either matches or loops over to the other side, you are done with the T-chart. Okay? This is the completed T-chart for the factoring T-chart of 16. Now 24, let's try this one out. Here we go. 1 and 24, you always start with the 1. Okay, 24 is even, so 2 goes into 24. Now you have to remember, so many people love doing GCF because it's like, oh, this is easy. I'll think of all my math facts. Remember, math facts are not the only math problems out there. You might go, oh, I don't know if 2 times a number that would be 24. It's because it's not math facts. I mean, it's not on that little sheet of paper that you probably did in elementary school. Okay, so 2. This is even, so 2 goes into it. Well, I know 2 dozen is 24, so a dozen is 12, so 2 times 12. Now, 2 plus 4 is 6. Does 3 go into 6?
Yes.
Yeah, so 3 goes into 24. Now we're kind of getting into the math facts part, right? 3 times 8 is 24. Now, 4, the divisibility rule of 4 is if 4 goes into the last 2 digits, then 4 goes into the bigger number. Well, here's the problem with this. 24 is the only 2 digits. It means if you're doing that only works if you're doing something like 5,024. You go, oh, 4 divides into 24, so 4 goes into 5,024. Okay? Now, if we're smaller numbers, here's usually the best way to do it. Can you split this number in half 2 times? Well, think about it. 24 split in half, we already said, is 12. And if that's an even number, it means it could be split in half again. Bottom line is if you can do that test, then 4 goes into that bigger number. You say, well, of course, Mr. Wilkins, because 4 times 6 is 24. Okay, the divisibility rule for 5 is, of course, if this number ends in a 0 or 5. Okay, well, that doesn't, so 5 can't go into it. Here's the divisibility rule for 6. If this side has a 2 and a 3 on it, meaning 2 goes into it and 3 goes into it, then 6 goes into it. But actually, we didn't have to do that. You know why? Because 6 is already on this side. We're done. That's it. You can put a 4 here if you want, but you just put 4 and 6 twice. You didn't have to do that. Now, these are all factors. They share, we were looking for the greatest common. They all have 1 in common. They have 2 in common. They have 4 in common. They have 8 in common, and that's it. Out of all of those, 8 is our greatest common factor. So step 2 is you're going to write down the greatest common factor, which is 8. Maybe where you don't confuse yourself on your notes, instead of you're finding the greatest common factor here you're writing it down, but you can also put that you're factoring for step 1. And then maybe you write down your GCF for step 2, okay, if you want to think of your notes that way. Now comes, that was elementary school kind of stuff. Now comes your 7th grade step, all right? And this is, remember, factors are all numbers multiplied together to come out with a number, right? Well, this being 7th grade and talking about variable expressions, okay, or algebraic expressions with variables, we have to realize that variables are also factors. So because of that, we're going to do step 3, which we are finding out, do they have any common variables? So take a look here. Do they have any common variables?
Yes.
What is it? M is our common variable. So because of that, M is also a common factor. So our greatest common factor ends up being 8M. And that's the answer. So 3 steps. The first step is time consuming, right? Factor both numbers. Second step is find your greatest common factor. And then ask yourself after that, is there a common variable? If there is not a common variable, then you don't put a variable there. Remember, these have to be common factors. So if there's no common variable, so if this was just an n here and there's nothing here, then you wouldn't put a variable in your answer. It's just the number, okay? Because you're just finding common factors. Okay, before I let you try one, any questions? Okay, here's the one I want you guys to try. I want you to try the very next problem, or I shouldn't say the very next. I want you to go underneath it and try problem 10. Problem 10, all right? Go. Remember, if you get stuck, use your notes. Guys, just a little reminder, don't forget to get your log signed. Tonight's the last night. You got about 30 more seconds to work right now. Okay, how many of you need more time on that problem? Okay. All right, checking with you in about 30 more seconds. Those of you that have it done, go ahead. You can work on that top section if you feel confident. Okay. Okay. 30 seconds. Okay, go ahead and turn to your neighbors. All right, here's what I would like you to do. I want you to share your answer. Now, it is possible that on this problem you could get the same answer, you can get the right answer, but your factor, your t-charts are not correct. Sometimes you get lucky like that, but it only works sometimes if you miss out on factors. What I'd like you to do is share your answer, but then after you guys share your answer, share your t-charts. Make sure you have the exact same factors, okay, on both your t-charts. All right? Okay, 30 seconds. Go ahead, turn to your neighbor and share. Go.
Okay, so for mine, I just think money right as I just remember I added
Okay, here we go. Just looking for an answer for right now. So answer to number 10, all right, seat 11. 25J. All right, so I'll write it up here, record your answer, 25J. All right, agree, disagree. What do you guys think? Okay, all right. Majority of you guys have that. All right, anyone have something different that they'd like to share? Okay, I'm going to go ahead. I'm going to do number 10 up here. Knowing how much room this takes, there's a decent chance you're going to want to use a separate piece of paper. All right, so for number 10, here's what I'm going to have. I'm going to start step 1, factoring my two coefficients in this case. It's 50 and 75. It's kind of funny because when you do t-charts, sometimes you get into a huge number. What you feel 50 and 75 is way bigger than 16 and 24. And sometimes they have a lot more factors. Sometimes they might even have less factors. So it just depends. All right. So 50, I'm going to do 150. Okay. I know 2 goes into it because it's an even number. 2 quarters equal 50 cents. So 2 times 25. 5 plus 0 is 5. 3 doesn't go into it because 3 doesn't go into 5. 50, let's see, can 4 go into it? Well, if I split 50 in half, it's 25. But 25 is an odd number. I can't split it in half again evenly. So 4 can't go into that. I do know that 5 goes into it. 5 times 10. 6, well, 2 is there, but not a 3. So 6 can't go into it. Okay, now I'm starting to get into math fact territory. 7 times 7 is 49, not 50. And then once I get to 8, I have now looped over, right? Because I just tried 7 and 7. So I can go 8, 9, and then I'm here at 10. That's it when it comes to factors for 50. 75, 1 and 75. 2 can't go into it because it's not even, right? 3, well, 7 plus 5 is 12. 3 can go into it. And I can punch it in the calculator real quick if I want. That does not excuse me from not showing my work for T-charts. Okay? I'm still recording my work, but if I want to use a calculator for that, I can. But I know 3 can go into it. I know 3 quarters, 3 25-cent pieces are 75 cents. 4, 75 is odd. Okay, so if I split it in half, I'm not going to be able to do that. So 4 can't go into it. 5 does. And if I want to use that, I could say 75 divided by 5 equal, oops, did I hit that wrong? 75 divided by 5 equals 15. Okay. 6 doesn't go into it because 2 doesn't go into it, right? 2 and 3 has to go into it for 6 to go into it. Okay. 7 times 11 is 77, so not 75. 8, now I'm starting to get into my math facts. 8 times 9 is 72. All right, too close, it doesn't work. And then now 8 times 9, right? Well, now I go to the 9. 9 times 8 is 70. I'm just looping over. So 9 times 8 is 72, 75. That's it. So here we go. If I take a look at these, 1, they share. 2, no, 5 they share. 10, 25 they shares are common. So I'm going to write down our 25 because that's what our greatest common factor is. Now common variables, if I look here, they both don't have K's, but they do have J's. So 25 times J, that is our greatest common factor. So nicely done. Okay, questions? Okay, so here is what I want to do really quickly is I want to go down to the bottom here. And I shouldn't say the bottom. Let's go to the middle section. I guess you'd call this a middle section. And let's take a look at problem 13. Now what we have here is we get in, this right up here is kind of it's not exactly your 7th grade standard you need to learn. This is your 7th grade standard. Okay. However, this is a stepping stone. You're going to see me, this is probably the hardest part of this part. You're going to see me use these steps on this skill. All right, so here is our set of directions. So let's go ahead and close read this. It says factor each
Expression.
if the expression cannot be factored, right?
Cannot.
Be factored. Okay, so we'll come back to this here in a second. Here's what I would like you guys to take a look at though, number 13. Here's what I want you to do for 13. I will let you copy it down. This is one of those problems I just want you to put your pencil down. I just want you to watch. Okay, after you watch, we'll do another one together after this. I'll let you write the steps. I just want you to watch me do this. Okay? So, here's what I'm going to do. It says factor each expression. So here's what we're going to do. I'm going to view 4x plus 12 as, instead of the addition sign, I'm going to pretend like they're 2 monomials, kind of like we did up here. I'm going to now factor my 2 numbers, my 4 and my 12. Now here's what I'm going to do. I am going to let you get away with not doing T-charts when you come to a problem that the smallest number can divide into the largest number. Remember the test when we were finding common denominators with fractions? And I said, guys, when the smallest number divides into the largest number, it helped you out. Well, the same that can be done here. If the smaller number divides into the larger number evenly, that is your greatest common factor. So only... I'm not going to do a T-chart on here, only on problems where that works, okay? So 4 is my greatest common factor. I take a look. Do they share a variable? The answer is no. Here is where this is different. I'm going to then write my parentheses. Then what I'm going to do is I'm going to look back at my expression and say, what is left over after I divide a 4 out? After I factor out a 4? Well, 4 times x, what is left is just the x. Positive 12, when I divide a 4 out, what is left? A positive 3. And that's our answer. Okay? So, believe it or not, all right, when it comes to that problem, there was no work to show because I didn't do t-charts, right? Up here, the only work we showed were t-charts. So when we don't do a t-chart, then there's really no work to show. Okay, it's all math facts. All right, strategic math facts, but math facts. Okay, I'm not going to let you guys ask questions yet because we're going to do step by step. Then I'll let you guys ask questions, okay? What I'd like you guys to write down first is go ahead and just basically write down the answer. If you want to put the little comma between these two to remember, that's fine, but the answer is the main part. Okay, now let's go ahead and do another one together with steps. All right, it's going to be a little more challenging. Let's go ahead and look at problem 21. Problem 21. Okay, here we go. You're going to see me write the first 3 are the exact same 3 steps. So here we go. Step 1 is we are going to factor. Remember the 2, we're going to start with just the 2 numbers. In this case, we're going to actually ignore the negative sign, and we're only going to focus in on 72 and 18. So 18, I don't know. Those are big numbers. I don't know if it goes in evenly with 72, so I'm just going to go ahead and factor them out with a t-chart. So 72 and 18. All right, here we go. 72 is 1 and 72. That's even, so 2 goes into it. If you need to use your calculator, 72 divided by 2 is 36. 7 plus 2 is 9. 3 goes into 9, so that means 3 goes into 72. If I don't know that, let me use a calculator. 72 divided by 3 is 24. If I split 72 in half, it's 36, which is an even number, and I can split that in half again. That means 4 divides into 72. Let me punch it in. 72 divided by 4 is 18. 5 doesn't go into it because it doesn't end in 0 or 5. 6 goes into it because 2 and 3 goes into it. So 72 divided by 6 is 12. 7 doesn't go into it, right? Because 7 times 10 is 70. 8 does go into it because now we're getting into math facts, and that is I'm gonna squeeze it in here. Sorry, guys. All right, 8 and 9. And look, the next number is 9. I already have it. Those are all my factors for 72. 18. Start on this. It's 1 and 18. It's even, so 2 and 9. Now we're getting into math facts, right? 8 plus 1 is 9, so 3 goes into 9, or better yet, math facts, 3 times 6. Split 18 in half, okay, is 9, okay, and you can't split 9 in half, so 4 doesn't go into it. 5 doesn't go into it, but 6 does, but we already have it. Greatest common factors, look at this, 18 and 18. Now, step 2, I write down my greatest common factor, which is 18. Step 3, is there a common variable to write down? No. This has an x, that has nothing. There is no common variable, so we don't write down a variable. Step 4. Parentheses. Write down your parentheses. It's an easy step. Now comes step 5. And we're going to call this the leftovers. The leftovers. Now what that really means is now comes division. Okay? Now if you did your t-charts correctly, this is an easy step. All right? All of the work is in step 1. The rest is just recording stuff down correctly. So here is what's left over. Okay? it started off with 72 minus 18x. So I look at the first term, and you say, well, Mr. Wilkins, that's hard. No, it's not. Look at your t-chart. 72, here's 18. You've already done your division. 72 divided by 18 is 4. 4 is what's left over in that first term. Okay? Then the second term, what's left over? Well, it's a negative, right? So this is going to stay negative because we divided by a positive 18. But look what's left over. A 1. Or in this case, 1x, which is just x. After I divided 18, 72 divided by 18 is 4, and 18 divided by 18 is 1, or just x, minus x. Okay. Now questions. So if you understood this, which it looked like most of you guys did, step 1, 2, and 3 are all that. Step 4, I'm pretty sure all of you guys can handle writing parentheses down, right? So that one's easy. Step 5, when in this particular problem, step 5 is the only, or in this section, is the only major challenging part then. So any questions on step 5? I mean, any steps, but step 5 in particular. Okay, before I let you try one, I want to ask you guys, okay? If you were to see this problem here, or even this problem here, as a math problem, and it said to simplify, which strategy would you use to simplify that? Distributive property. Ladies and gentlemen, factoring linear expressions, you know what it is? It's the opposite of doing distributive property. They're giving you the answer, and you have to write the problem. That's basically what we're doing. They're giving you the answer, you have to write the distributive property problem. That's what factoring is. If you ever want to check to see if you got the right answer, just do distributive property. 4 times x is 4x. 4 times positive 3 is positive 12. Ta-da! Okay. So that's what we're doing. Okay. Any questions before I let you guys try one? Okay. Here's the one I want you guys to try. Try out problem number 15. 15. All right. Go. Okay, just checking in with you guys. How many of you need more time? Okay, give you about 30 more seconds. Okay. All right, so I want you to share your answer, but I want you to show the person what your answer is. You could say it out loud, but I want to make sure that you guys are clear, because some of us, I think, struggle with saying this correctly. So make sure that the parentheses are there, along with, of course, the correct numbers, okay, and the correct sign, which is very important too. So 30 seconds. Go ahead and turn to your neighbor and share. Go. Okay, so thank you those of you. I don't mind you guys going a little over when you're talking about this problem, but if you've already talked about it and you're having a little side discussion, make sure you're ready to go when that ring goes off. All right, here we go. So just want to check in with you guys and see what some answers are out there. All right, seat 18. Okay. Agree, disagree? What do you guys think? All right, a lot of agreements. Okay, anyone have something different? Okay. All right, well, let's check it out here. So 5x plus 35. Now, if you could have easily done a chart, but remember I told you that on the problems where the smaller number divides evenly into the bigger number, you don't have to show a t-chart. So bottom line is remember the 5 is going to be your greatest common factor. So that comes out. Then we take a look and say, okay, well then what is left over? Well, 5 times x, what's left over is just the x. And then when I divide the positive 35 by 5, I get a positive 7. And so, of course, that would be correct. All right. Obviously, there were no common variables, so I didn't have to worry about factoring out a variable. Okay, questions on that? Okay, what I want to do, what I also want to do is I want to show you just a different way that you might see on a quiz, on a test, things that will be popping up on how this is written. Now, before we do that, I just want to take time really quickly. See where it says cannot be factored? That means, what if you do two t-charts and the only number they share is 1? Well, think about it, right? Let's pretend 22 is one of those problems. What if you divided both and you divided out a 1? What would go inside? 25x plus 14, right? Dividing by 1 doesn't do anything. So when your only common factor is 1, or your greatest common factor is 1, then you would write cannot be factored, because there's no need to factor out a 1 because you're not doing anything. So that's what it means by cannot be factored. Okay. Any questions about that part? Okay, so here's what I want to show you. There's a different way that these problems can be asked on quizzes, on our chapter test, on state testing, and go ahead and flip the paper over. All right, let me show you what they look like. Okay, so take a look at problem number 5. Let's take a look at 5. And then look up here. It says fill in the missing information for each dimension and area as a sum or difference, right? I mean, it gets a little wordy, but what this is ultimately saying is each dimension is talking about the factors, right? This is what this is this is the opposite of distributive property with using the area model method. That's what this is, okay? So you're going to do the exact same thing that we did on the other side. Same exact steps. So here we go. Step 1 is take your numbers. Okay, thank you for reminding me of that. Step 1 is take your numbers and let's factor them. So t-charts 8 and 20. So 8 is 1 times 8, 2 times 4, 3, no, 4, yes, but it's already there. Okay, these are nice and easy, right? 20 is 1 times 20, 2 times 10, not a 3, but yes, a 4. 4 times 5, and the next one is 5, but we already have it. So I'm looking here, our greatest common factor is a 4. Now, here's what I want to point out. First of all, most of the time you'd put it to the left, but look what they do. They try to trick you, and they put that factor over to the right. Remember, we talked about that before. Okay, this over here multiplied with this expression, or this multiplied with this expression, it doesn't matter, right? Commutative property of multiplication. So we can put our factor here. Now, here's the only thing I want to say during this time. We'll call this step star, just as a little reminder. When both factors are negative, you actually factor out the negative. You see how this is negative 8 and negative 20? What we're going to do is we're going to not factor out a positive 4, we're factoring out a negative 4. Factor your negative out if both terms are negative. Okay, so we go through the step 3, right? Do they have a variable? No, they don't have a variable in common, right? Step 4 is put parentheses, which on this case right now anyway we don't have to do. All right. Step 5 is write what's left over. So in this one, once I divide by a negative 4, I look here, the 2 is left over. So I put the 2. Now this is a positive 2 because, right, negative 8 divided by a negative 4 is positive 2. Don't forget, of course, your x, right? The x is left over in that term as well, so don't ever forget your variables. And over here, negative 20, I divided out a negative 4. Well, our other number is a positive 5. Now, they give us this little line, and here's why, because they want us to rewrite it in this form here. Okay, so when you factor, that's the final form they want you to write it in. So unless this is state testing and the computer just gives you these 3 boxes to put them in, then you would just put the boxes in, that would be it. But if there's a line like this, they want you to put it in that form on the other side. So here's what we do. Negative 4 was our factored number, right? Our greatest common factor. We put it down. Again, we put our parentheses. And we write this out as an expression. So it's 2. Don't put 2x5 because that means 2 times x times 5. That's not what this is. It's 2x. Remember, this is a positive side of 5. So it's 2x plus the 5. And there is your answer. Okay, questions on that? Okay, guys. So factoring linear expressions.